Hello, this is Investigation 5. This is called Organizing and Analyzing Data. Now, you aren't going to have any practice problems on this lesson, so you do need to take good notes on this lesson and what is on the board and the things that I tell you to. So, the first thing that we can look at when we organize data, and just kind of as an introduction a little bit, when we organize and analyze data, there's people that do that actually in everyday life, and it's actually very helpful, and it helps businesses produce the needs the goods that they need. It helps schools and churches and many groups and organizations figure out what kind of people they're bringing in, what kind of people they have and are including. And when they organize and analyze that data, that way they're able to figure out the needs, they're able to figure out what is going on, and it happens all the time around us. And those people are usually called statisticians that keep track of a whole bunch of data and collect surveys or use surveys to collect data. So one way that you can collect data is through a frequency table. Now, a frequency table collects the frequency of the number of answers that they have, usually using tally marks. So that's kind of a key thing to remember, is that usually using tally marks is when you create a frequency table, or how to create a frequency table. So this is the number of the scores that were collected from a 6-question answer quiz. Now, 6 is the most you can get, so these aren't all bad scores. So the way I would collect the data is count how many ones. I have 1, so I'm going to put 1 tally mark. So for 2s, I count 1, 2, 3, 4. That's 4 people made 2, so I'm going to put 4 tally marks. 3, for the number of people that got 3 correct is 1, 2, 3, 4, 5, 6, 7. So I'm going to do 7 tally marks. 1, 2, 3, 4, crossover for 5, 6, 7. And then 4 correct. 1, 2, 3, 4, 5. 1, 2, 3, 4, crossover for 5. And 5. 1, 2, 3, 4, 5. Again. 1, 2, 3, 4, 5. And for 6, there's 3 people that got 6 correct, or got all 6 correct. And then when I write down my frequency here is basically how many tally marks I have in this column. So there's 1, I have 4 here, I have 7 here, 5, 5, and 3. So this is collecting the frequency of the amount of people that made certain scores. Now you do need to keep track of that because you are going to be creating a frequency table in class. And then we also have line plots. These may look familiar. I believe you probably learned these in 4th grade, especially maybe some of these terms. Line plots kind of collect across a number line, and you use X's or use some sort of symbol to represent each person or to represent each score that was made. Now these are the ages of people that went down a certain water slide. So you have a range, not necessarily of people, but the line shows an age range between 5 and 25. So here's the data that was collected. We have what's called a cluster right here. This is between the ages of, let's see, this is 11, 12, and 13. So between the ages 11 and 13, we have what's called a cluster. That's data points that are very close together. So there's a group of data points that are all very close together, and it's a lot of them, which makes it a little bit more different than a cluster right here where you have one of 15, 16, and 17, or a few of 9 and 8. Then we have what's called an outlier. It's data point that is distant from the majority. I want you to write these words down under line plots because an outlier is a data point that is distant from the majority. And we would say that this group between 21 and 22 are outliers because they're kind of out there, a little bit older than the rest of them, of the people going down the water slide. So from this data collected here, we can actually tell how many people that were collected, or as far as surveyed, that went down the water slide. We know there are different age ranges, all the way from 8 years old to 22 years old, and we can tell a lot more information from these line plots. You will also be collecting data and graphing it on a line plot as well, so be sure to remember this. Then we also have bar graphs and line graphs, which are usually the very most common that you see on computers, you see on the internet, and you're probably very familiar with these. So I'm just going to briefly kind of go over on how to read these. With bar graphs, of course, you use bars that can either be actually vertical or horizontal. This one has a number of students and their favorite foods. We can tell pizza, this is hamburgers, spaghetti, and tacos. So from this data, I can tell how many students were surveyed. We have 9 here under pizza. We have 6 for hamburgers, 5 for spaghetti, and 8 for tacos. I could add all of them up and figure out how many students were surveyed. I can also figure out which one has more and by how much. Pizza is the most popular, spaghetti is the least popular, and there's 9 for pizza, 5 for spaghetti, so 4 more students like pizza than they do like spaghetti. So I can kind of compare different results. On this line graphs, of course, use lines. And this is the number of problems corrected, or that were correct on a test. The test was out of 20 questions. So I have 20 up here, and it's anywhere between 16 here and 19 correct here. So I can kind of tell how many were correct on each test, being test 1, test 2, test 3, test 4, test 5. Now notice that these graphs, bar graphs and line graphs, are all labeled. I have different axes. I have a horizontal axis here and vertical axis here. Same thing here. Vertical axis, horizontal axis. They all involve numbers. So they all have numbers. They're all numerical data. But this one is just test 1, test 2, test 3, test 4, test 5. But these are my important numbers that I'm graphing of how many are correct. Because here on my horizontal axis, I have words going across. I have pizza, hamburgers, spaghetti, and tacos, but I have the numbers that I'm graphing, the number of people that like each of those foods. So that's an overview of organizing and analyzing data. We will be collecting data in class with each other and using the frequency tables and line plots, since those are probably the least used data, collecting the least used data and way of organizing that you usually see. So we're going to become more familiar with those. Thank you very much for listening.